All right, now part 2 of this particular problem, we have an example. We've already talked about the idea behind digit problems, so now let's do an example. The sum of the digits of my grandfather's age is 15. The sum is 15. Reversing the order gives an age that is 9 years younger. The question is, how old is he? So we're going to set this up using the ideas that we just talked about in the previous video. First, as before, we'll let t equal the tens digit. And we'll let u equal the units digit. Now, the first part of this we have is that the sum of the digits of his age is 15. So the sum of the digits is 15. So then the sum of the digits, t plus u, equals 15. That's it. That's our first equation. We have two equations, or we have two unknowns, so we're going to need two equations. Fortunately, we have another piece of information. Reversing the order gives a number that is 9 years younger. So remember again how we reverse the order. The original number is 10t plus u. That's how we would write the original number. The reversed number then is 10u plus t. That doesn't make sense, remember, go back to the previous video and check that out again. But remember again, we could do 59 versus 95 by just swapping the two numbers. This would be 5 times 10 plus 9. This would be 9 times 10 plus 5. There's going to be a plus or minus 9 somewhere in here, but you actually got to pay attention to where you put it. You really got to think about it for a moment. And what I'd like to think about is this. When we reverse the age, the reversed age is younger than the old age. So that means, essentially, we have this relationship, that the actual age is greater than the younger age, the reversed age. The actual age is greater than the reversed age. What this means is that, it's specifically 9 years younger. So if I want to make this an equation, I can add 9 to that side because that's the smaller side, and that will make these two things equal to each other. I could have also subtracted 9 from that side. It is obviously the same thing. Adding or plusing 9 to this side and minusing 9 from that side would be the same result. So it doesn't really matter which side you put it on. So think about when you're given questions like this where one is less than the other by a certain amount, just make the inequality first, and then think about which side you would have to put the plus 9 or the minus 9 on in order to get it to work out. But now we have a system of equations that we'll go ahead and solve. But here I'm going to move everything to one side first. So I'm going to minus t and from both sides. I'm actually going to move the 10u as well. Move that over. So I get 9t minus 9u equals, 9. So this is my equation that I'll compare with this one. I'm going to write them over again over here with my brackets. So t plus u equals 15, and 9t minus 9u equals 9. And I'm going to give myself a little bit of space to work with now. I should have given you a warning on that. Go back and pause if you need to write that down again. But these are my two equations that I have. Now I can work with these. I can use substitution. I could subtract u from both sides and then plug in for t. I'm going to use elimination, actually. I'm going to multiply the top here by 9. And I get 9t plus 9u equals 15 times 9. 15 times 9. 9 times 5 is 45. Carry the 4. 9 times 1 is 9. So 135. 135. Bottom equation has not changed. 9t minus 9u equals 9. Now we'll add them together. 9t plus 9t, 18t. The 9u and negative 9u cancel. That's the whole point of elimination. And then 135 plus 9 is 144. And now, of course, we just divide both sides by 18. and I'm going to move this over to here, I get that t is equal to 8. So t, the tens digit, is 8. To find the ones digit, I could just go back to probably this equation here and do 8 plus u equals 15. So just subtract 8 from 15. And that gives me that u is equal to 7. Now keep in mind, this is not my answer, because this doesn't answer my question. The question is, how old is he? So I have that the tens digit is 8, the units digit is 7, so that means that he is 87. 87 years old. And if we swap the order, 87 becomes 78, and 87 minus 78 is indeed 9. So we do get that relationship there. So now you can work your way through some of the other problems on your worksheet there, numbers 9 and 11 again. And if you have questions, again, check out the textbook. Maybe that'll help you out. But then you know where to go to. Talk to your teacher.